Hi, this is Kirtana, currently pursuing my civil engineering in Sri Venkateshwara College of Engineering. Let us discuss about the plate bearing test on rigid pavement, which is related to the topic transportation engineering with the subject code 21 CV52. Introduction to the plate bearing test. The plate bearing test is critical component in the design of rigid pavement in highway engineering. It measures the load bearing capacity of the soil subgrade. The results obtained from the plate bearing test help in determining the thickness of the pavement layers. Purpose of plate bearing test. The main purpose of plate bearing test is to evaluate the strength and stiffness of the soil subgrade. It helps in determining the sustainability of the soil for supporting the rigid pavement structure. The test provides valuable data for pavement design and helps in ensuring long-term durability. Test setup. The plate bearing test involves using a steel plate, usually 300 mm in diameter. The plate is placed on the compacted soil subgrade surface. A hydraulic jack applies a load to the plate and the resulting deformation is measured. Test procedure. The plate bearing test is conducted in accordance with standard procedures such as ASTM D1196. The test load is applied in increments and the corresponding settlements are recorded. Typically, 3 or more load increments are applied to determine the load settlement behavior. Data analysis. The plate bearing test data is analyzed to determine the modulus of subgrade reaction. The K value represents the stiffness of the soil subgrade and is used in pavement design calculations. The test results helps in determining the appropriate pavement thickness and layer composition. Factors affecting test result. The plate bearing test results can be influenced by various factors such as moisture content and compaction of subgrade. Soil type and density also play a significant role in determining the load bearing capacity. Proper consideration of these factors is crucial for accurate and reliable test results. Importance of plate bearing test. The plate bearing test provides essential data for designing rigid pavements with adequate load bearing capacity. It helps in optimizing pavement thickness, reducing construction costs, and ensuring long-term performance. Without this test, the pavement may fail prematurely, leading to costly repairs and potential safety hazards. Limitations of plate bearing test. The plate bearing test has limitations in representing real-world conditions accurately. The test measures the load-bearing capacity of small area which may not fully represent the subgrade behavior under a larger pavement section. Therefore, it should be used in conjunction with other tests and engineering judgment. Case Study 1. Plate bearing test conducted on highway A showed a subgrade modulus of 150 mn per meter cube. This data was used to design the rigid pavement with a thickness of 250 mm. The design successfully met the specified design life and performance requirements. Case Study 2. Plate bearing test conducted on Highway B indicated a subgrade modulus of 80 mn per meter cube. Based on this data, a pavement thickness of 200 mm was designed. The design performed well under the normal traffic loads but experienced some distress under heavy truck traffic. Advantages of plate bearing test. The plate bearing test is a cost-effective method for evaluating the soil subgrade strength. It provides valuable information for pavement design without the need for extensive excavation or testing. The test can be conducted relatively quickly, allowing for efficient decision making during the design phase. Test standards. Various test standards are available for conducting the plate bearing tests such as ASTM D1196, AASHTO T222 and BS 1377. These standards provide guidelines for equipment, test setup, load increments, and data analysis. Following the appropriate standards ensures consistency and reliability in test results. Plate bearing test equipment. The plate bearing test requires specific equipment including a steel plate, hydraulic jack, dial gauge, and load frame. The loading frame should be capable of applying loads up to the desired maximum design load. Calibrated instruments and proper equipment maintenance are essential for accurate test results. Plate bearing test application. The plate bearing test is widely used in designs of highways, airports, industrial pavements, and other rigid pavement structures. It is applicable for both new construction projects and rehabilitation of existing pavements. The test helps in optimizing pavement designs for various traffic loadings and subgrade conditions. Plate bearing test consideration. Prior to conducting the plate bearing test, site investigations should be performed to assess soil properties, moisture content and compaction. The test should be conducted at representative locations along the pavement alignment. Proper safety precautions should be taken during test setup and execution. Plate bearing test reporting. Test results should be documented in a comprehensive report including details of the test setup, equipment used, and the test procedure. The report should include the load settlement curves, K-value determination, and recommendations for pavement design. Clear and concise reporting facilitates effective communication among project stakeholders. Plate bearing test validation. The plate bearing test results should be validated through field performance monitoring and evaluation. Long-term pavement performance data should be collected and compared with the design assumptions. This feedback loops helps in improving future design and ensuring the accuracy of plate bearing test. Conclusion. The plate bearing test is crucial tool for designing rigid pavements in highway engineering. It provides valuable data to determine the load bearing capacity of soil subgrade. By optimizing pavement thickness and layer composition, the test helps in ensuring long-term pavement performance.